According to the 2005 National Electrical Code, the maximum distance permitted from the point where service entrance, or C, cable enters a dwelling to the nearest service disconnecting means is 10 feet, or 3.5 meters. This requirement is explicitly outlined in Section 230.70a of the NEC. However, there is an exception. If the SC cable is installed within a raceway, the allowable distance to the service disconnect can be extended to a maximum of 25 feet, or 7.62 meters. This exception is detailed in Section 230.70 Atwo of the NEC. Let's delve deeper into these requirements and their implications for electrical installations. The primary reason for limiting the distance between the point of entry and the service disconnect is safety. In the event of an electrical fault or emergency, it's crucial to be able to quickly de-energize the electrical system. A readily accessible disconnect located close to the entry point allows for a rapid and effective shutdown, minimizing potential hazards such as electrical shock or fire. Section 230.70a specifically addresses situations where the SC cable is not enclosed in a raceway. This means the cable is directly exposed within the building structure. In such cases, the 10-foot limit applies to ensure the disconnect remains easily accessible. The 10-foot distance is measured along the actual cable route from the point where it enters the building to the location of the service disconnect. This measurement takes into account any bends or turns in the cable run. It is not a straight line measurement. Now, let's consider the exception provided in Section 230.70 Atwo, which permits a longer distance of 25 feet if the SC cable is installed in a raceway. A raceway is an enclosed channel designed to hold and protect electrical wires and cables. Common examples of raceways include electrical metallic tubing, or EMT, rigid metal conduit, or RMC, and PVC conduit. When SC cable is installed within a raceway, it gains additional protection from physical damage and environmental factors. This increased protection allows for a slightly extended distance to the service disconnect, recognizing the reduced risk of cable damage and the corresponding potential for electrical hazards. It's important to note that the raceway must extend the entire distance from the point of entry to the service disconnect in order to qualify for the 25-foot exception. Partial raceway installations do not meet the requirements of Section 230.70 Atwo, and the 10-foot limit would still apply. The NEC provides these specific distance limitations to ensure electrical safety and to facilitate the rapid energization of electrical systems in emergency situations. Compliance with these requirements is essential for all electrical installations. Understanding the difference between installations with and without raceways is key to applying the correct distance limitation. Let's break down the practical implications of these rules with some examples. Firstly, consider a scenario where SC cable enters a dwelling directly through an exterior wall and runs exposed along the basement ceiling to the service panel. In this case, the 10-foot rule applies. The distance from the point where the cable enters the wall to the service disconnect within the panel must not exceed 10 feet. Secondly, imagine an SC cable entering a dwelling and immediately transitioning into a PVC conduit run that extends to the service panel located in a more remote part of the basement. In this scenario, the 25-foot rule applies as long as the conduit provides continuous protection for the entire length of the cable run. Thirdly, if SC cable enters a building and is run exposed for 5 feet, then enters a conduit for another 15 feet before reaching the service panel, the installation does not comply with the 25-foot rule. The exposed section of the cable limits the total allowable distance to 10 feet. The rules discussed apply specifically to single-family dwellings. The requirements may differ for other types of buildings, such as multi-family dwellings or commercial structures. It's always crucial to consult the NEC and any applicable local codes to determine the specific requirements for each type of installation. Furthermore, the service disconnect must be readily accessible. This means it must be located in a place where it can be easily reached without the need to climb over obstacles or move obstructions. The disconnect should also be clearly labeled to identify its purpose and function. Proper labeling is essential for facilitating a quick and effective response in emergency situations. In addition to the distance limitations and accessibility requirements, there are other important considerations for installing SE cable. The cable must be properly supported and secured to prevent physical damage. It should also be protected from exposure to moisture and corrosive substances. The NEC provides detailed requirements for the installation of SE cable, covering topics such as conductor sizing, overcurrent protection, and grounding. It is crucial to consult the NEC and follow all applicable requirements to ensure safe and compliant installation. Local electrical codes may also impose additional requirements or restrictions on the installation of SE cable. It is essential to be aware of and comply with all applicable local codes in addition to the NEC requirements. Electrical inspections are typically required for new electrical installations and modifications to existing systems. An electrical inspector will verify that the installation complies with the NEC and all applicable local codes. It is important to schedule an inspection and obtain approval before energizing a new or modified electrical system. Failure to comply with electrical codes can result in fines, penalties, and the potential for electrical hazards. In summary, the 2005 NEC specifies a maximum distance of 10 feet from the point of entry of SE cable into a dwelling to the nearest service disconnect, unless the cable is installed in a raceway, in which case the maximum distance is increased to 25 feet. These requirements are designed to ensure electrical safety and to facilitate the rapid de-energization of electrical systems in emergency situations. Compliance with the NEC and all applicable local codes is essential for all electrical installations. Always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirement. If you are unsure about any aspect of electrical installation, it is always best to consult with a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety and safety of others. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Furthermore, it's important to understand the definition of service entrance cable. Service entrance cable is a type of electrical cable specifically designed to bring power from the utility company's service drop to the building's service equipment. It is typically a multi-conductor cable with a concentric neutral. The NEC defines service entrance cable in Article 338. It's crucial to use the correct type of cable for service entrance applications. Using the wrong type of cable can create a safety hazard and violate electrical codes. Also, it's important to consider the ampacity of the SE cable. The ampacity is the maximum amount of current a cable can safely carry. The ampacity must be sufficient to handle the expected load of the dwelling. The NEC provides tables that list the ampacity of different sizes and types of conductors. These tables take into account factors such as conductor material, insulation type, and ambient temperature. Selecting the correct size of SE cable is crucial for ensuring safe and reliable operation of the electrical system. Undersized cable can overheat and cause a fire. Oversized cable is more expensive and may not be necessary. The service disconnect is typically a circuit breaker or a switch that can be used to disconnect all power to the building. The disconnect must be readily accessible and clearly labeled. The location of the service disconnect is often determined by the utility company. In many cases, the utility company requires the disconnect to be located on the outside of the building. This allows utility workers to disconnect power to the building in case of an emergency. The NEC also requires a grounding electrode system. The grounding electrode system provides a path for fault current to flow back to the source. This helps to protect people from electrical shock. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system must be properly connected to the service equipment and to the building's metal components. Proper grounding is essential for electrical safety. In addition to the NEC requirements, there may be local utility company requirements for service entrance installations. It is important to contact the local utility company to determine their specific requirements. The utility company may have requirements for the location of the service equipment, the type of meter base, and the grounding system. Complying with the utility company's requirements is essential for getting the electrical service connected to the building. When installing SE cable, it is important to follow all safety precautions. Always disconnect power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety. Furthermore, consider the potential for future expansion when planning the service entrance installation. It is often a good idea to install a larger service entrance than is currently needed. This will allow for future additions to the electrical load without having to upgrade the service entrance. For example, if you are planning to add an electric vehicle charger or a larger appliance in the future, you may want to consider installing a larger service entrance. The cost of upgrading the service entrance later can be significantly higher than installing a larger service entrance initially. Finally, remember that electrical codes are constantly evolving. It is important to stay up to date on the latest changes to the NEC and any applicable local codes. The NEC is typically updated every 3 years. Changes to the NEC can affect the requirements for service entrance installations. It is important to be aware of these changes and to comply with the latest requirements. Also, different jurisdictions may adopt different versions of the NEC. Be sure to check with your local building department to determine which version of the NEC is in effect in your area. Adhering to the latest electrical codes ensures the safety and reliability of the electrical system. Failing to comply with electrical codes can have serious consequences, including fines, penalties, and the potential for electrical hazards.